Surface integrals. Given a parameterization of surface RUV equaling XUV, YUV, ZUV, the parameter domain of the parameterization is the set of points in the UV plane that can be substituted into R. So if you look below here, it says for the following exercises, find parametric descriptions for the following surfaces. So we're going to just do both of these. Now, the parameterization we're looking for is we're turning these equations here into the parameterization of RUV. And this is big for the rest of this class on, to be able to convert any equation into RUVs. So this first one is a plane, and this one's actually very simple. So the idea here is I have two variables, u and v, in which I have to figure out how I'm going to use u and v to describe the plane 3x minus 2y plus z equals 2. So right away I can look at this and say, hey, I can let my u equal x and my v equal y. So then if I take those two components and I'm saying, okay, so then for my RUV, for my first component, this is my x component here in general, that will be u. And then for my y component next, that's going to be v. Now what changes here is my z. So now for this equation, I'll have to plug in my u and my v, and then I can actually find z. So what I mean by that is I'll say 3u minus 2v, because that's what we said they were, plus z equals 2. And then if I solve for z, z is going to equal 2 minus 3u plus 2v. So that's what's going to go in place of z here for the third component. And that'll be 2 minus 3u plus 2v. And honestly, it is that simple. Once I assign those variables, that's it. Now, anytime I'm dealing with something like, let's take 274, for instance. Now, we're going to do this with a paraboloid. And I guess what I should do for this is write 273 here. And then down here, 274. Okay, so this one's a paraboloid. Now, what do I want to let my u's and v's be? I think a good way to go with this would be cylindrical. So if you think about the parameters for cylindrical, it's x equals r cos theta, y equals r sine theta, and z equals z. And what we're going to do here is we're just going to do this same thing here. So I can let my u equal theta and my v equal r. And from this, if you can think of this in terms of polar, that means my x, let me write my RUV first. That means my x component, which is the first one here, is going to be v cos u. And my second component is going to be v sine u. And again, it's just from direct subbing in there for those two components. Now it says z is z, but keep in mind here, we do have a parameter here in which z is dependent upon. And it's dependent upon x and y, which is these components here. So since I'm converting to polar though, I have to think about my other equations. I also have x squared plus y squared equals r squared, and tan of theta equals y over x. And we can see here that x squared plus y squared is r squared. So that means my z equals r squared. Now the interesting thing about this is, remember my previous sub. I know v equals r. So really what we're saying here then is this implies that z equals v squared. So this would be comma v squared. So again, once we do our subs, and it's only going to be for two variables, we're going to have to work the third one out using one of the equations. And that's fine. Now keep in mind here that my z equals v squared. And notice for z, for this one, we have parameters for this. So we're going to have to take into account those parameters. So that's what we're going to deal with now. So like I said a minute ago, remember z equals v squared. So really what I have here is 0 less than or equal to v squared less than or equal to 9. And then if I square root both sides, I'm going to get 0 less than or equal to v less than or equal to 3. So I will need these parameters as well. Like this thing I can move over, get it out of the way. This I can move over a little bit, just so it doesn't get confused with my answer. And this is actually part of the answer as well. So if I wanted to circle my answer here, that's how I do it. So there we go for the second one, and for the first one, this is my parameterization of the first one here. First one had no parameters, so, no bounds, I should say, for any of my variables, so I'm just left with this.